Your watch is lying to you. Every second you experience is a personal hallucination, shaped by how fast you move. Time is not a constant. It's a flexible trap that stretches, shrinks, and breaks to keep the cosmos in check. Welcome to Lucid Cosmos. Tonight, we're diving into the question, why does time slow down at high speeds? Deep within the pocket of your genes, tucked away in the silent background of your digital existence, a ghost is whispering. It is the ghost of Albert Einstein, and it is the only reason you are not lost. Right now, as you sit still, you feel constant. You feel as though a second for you is a second for the person next to you, a second for the bird in the sky, and a second for the stars burning in the black velvet of space. You are wrong. Every intuition you have about the passage of time is a comforting lie told to you by your limited human senses. The terrifying, beautiful truth is that time is not a steady river. It is a violent, malleable, and hauntingly fragile ocean. And we know this not because of philosophical dreaming, but because of a cold, hard fact. If we did not account for the warping of time, the very world you live in would collapse into geographical chaos within 24 hours. Your phone's GPS is the most profound proof of a broken universe ever placed in the hands of the public. Orbiting high above our heads, 30 satellites are screaming through the void at 700 miles per hour. At those speeds, time itself begins to surrender. Because they move so fast, the clocks on those satellites lose about 7 microseconds every single day relative to us. But the mystery deepens. Because they are nestled in the thin gravity of high orbit, far from the heavy mass of Earth, time actually speeds up for them by about 45 microseconds. When you do the celestial math, the net result is a haunting discrepancy. Satellite clocks run 38 microseconds faster per day than yours. You might think that 38 millionths of a second is a triviality, a mere hiccup in the grand scheme of a life. You would be catastrophically mistaken. Light and radio signals travel at a blistering 1 foot per nanosecond. If the engineers behind your GPS ignored Einstein for just one day, the timing error would accumulate so quickly that your perceived location on the map would drift by 6 miles every 24 hours. You would be looking for a coffee shop on a familiar street corner, while your phone insisted you were standing in the middle of a lake 2 towns over. The precision of our modern life is built entirely upon the fact that time is a shapeshifter. This isn't just about navigation. It is about the fundamental instability of what we call now. We are living in a reality where the faster you move, the less you age. We are living in a universe where the fabric of existence stretches and tears based on nothing more than your velocity. It is a mind-bending, bone-chilling realization that the universe has a speed limit, and it will break time itself just to ensure that limit is never surpassed. Why does the cosmos behave this way? Why is time the sacrificial lamb at the altar of light? If you find yourself shivering at the edge of this cosmic rabbit hole, you are in the right place. To ensure you never miss a journey into the deep unknown, please subscribe to Lucid Cosmos right now. Your support is the fuel that allows us to venture further into the mysteries that define our existence. By joining us, you aren't just watching a video. You are becoming a seeker of the truth in a world that often prefers the comfort of the surface. Let us descend further. To understand how a satellite can be in the future compared to your phone, we have to look at the very foundation of the universe. Imagine you are standing on a dark, lonely platform. A train thunders past you at half the speed of light. On that train, a traveler shines a flashlight toward the front. To your common sense, that light should be moving at the speed of the train plus the speed of light. But the universe says, no, the light moves at exactly 299,79,458 meters per second, always, no matter what. This is where the horror and the wonder of physics meet. Since the speed of light cannot change, something else has to give. Like a safety valve on a high-pressure engine, time itself dilates. From your perspective on the platform, you would see the traveler's watch begin to tick with agonizing slowness. Their heartbeat would slow. Their thoughts would stretch. To them, everything feels normal, but to you, they are becoming frozen in a temporal amber. This is not a trick of the light or an optical illusion. It is a literal physical transformation of the fourth dimension. We have proven this. We have put atomic clocks on commercial airliners and flown them around the globe, only to find they returned younger than the clocks that stayed in the terminal. We have watched subatomic particles in the Large Hadron Collider, particles that should have died in a microsecond, survive for thousands of times longer simply because they were moving so fast that time forgot to kill them. The universe is telling us something profound. Time is the price we pay for motion. Every time you drive your car, every time you run, every time you even shift in your seat, you are engaging in a tug of war with the passage of eternity. You are a time traveler in the most literal sense, drifting through the days at a rate slightly different from the person standing still. As we prepare to dive into the even more shocking secrets of the Lorentz factor and the terrifying implications of the twin paradox in the next segments, I want you to stop and truly consider the ground you are standing on. You are not moving through a static world. You are moving through a flexible, breathing tapestry of space-time that reacts to your every move. Before we move into the mechanics of how Einstein broke and then rebuilt the laws of physics, I want to pose a question to you, a question that strikes at the heart of your own existence. Think deeply about this and leave your answer in the comments below. We want to see how you perceive the weight of this reality. If you were offered the chance to board a ship that would travel at 99.9 the speed of light for what felt like only 1 year to you, knowing that when you returned to Earth, everyone you have ever known would be dead, and a century would have passed, would you go? A yes, I would sacrifice everything to see the distant future and witness the evolution of humanity. B, no, time is only meaningful because of the people we share it with. A future without them is a hollow void. Drop an A or a B in the comments. Let's see how many of you are willing to pay the ultimate price for the ultimate journey. Your answers will help us shape the discussion as we explore what happens when we push the limits of speed to their absolute, soul-crushing extreme. Stay tuned. The journey into the heart of lucid cosmos is only just beginning. The sanctuary of common sense is a fragile place, and Albert Einstein was the man who burned it to the ground. To understand why time stretches, we have to confront the most uncomfortable truth in physics. The universe does not care about your logic. In our everyday lives, speed is a simple game of addition. If you are standing on a train traveling at 100 miles per hour, and you throw a baseball forward at 50 miles per hour, any observer standing on the side of the tracks will see that ball streaking through the air at 150 miles per hour. This is Galilean relativity, the comfortable, predictable world we've lived in for centuries. It suggests that speeds are cumulative, that motion is additive, and that time is a universal drumbeat, steady and indifferent, ticking at the same rate for the man on the train and the man on the ground. But then, light enters the room, and the rules of the game are shattered forever. Light is the ultimate rebel. It is the only thing in the known universe that refuses to move faster just because you are helping it. Imagine you are on that same train, but instead of a baseball, you click on a flashlight. Common sense screams that the light should be traveling at the speed of light, plus the 100-mile-per-hour velocity of the train. But it isn't T. Whether you are standing on the platform, racing toward the light in a supersonic jet, or fleeing from it at half the speed of light, the beam will always pass you at exactly 299,792,458 meters per second. This is the speed of light in a vacuum, a number so sacred and so stubborn that it dictates the very geometry of existence. This was Einstein's radical realization. The speed of light is the absolute constant, the police officer of the cosmos. And if the speed of light refuses to change, Then something else, the very fabric of time, and space must be the thing that yields. To grasp the magnitude of this sacrifice, we must envision the universe's internal clockwork. Think of a device called a light clock. It's a simple theoretical machine. Two mirrors facing each other with a single photon of light bouncing back and forth between them. One tick of this clock is the time it's for, the travel from the bottom mirror to the top and back again. If that clock is sitting still on a table in front of you, the photon moves in a straight vertical line. But now, imagine that same light clock is on a spacecraft screaming past you at 90% the speed of light. To you, watching from the outside, the photon is no longer moving in a simple up and down line. Because the clock is moving forward at incredible speed, the photon must travel along a diagonal, zigzag path to catch the mirrors as they move. Here is the moment where reality bends. The diagonal path is significantly longer than the vertical path. In our old, comfortable world of physics, we would simply say the photon is moving faster to cover that extra distance in the same amount of time. But remember the law. Light cannot speed up. It is forbidden. Therefore, if the photon is traveling a longer distance at the same fixed speed, it must take more time to complete a single tick. From your perspective, the clock on that spacecraft is ticking slower. The traveler's heart is beating slower. Their very atoms are vibrating at a reduced frequency. This isn't a mechanical failure of the clock. It is a fundamental dilation of time itself. Space and time are not separate entities. They are woven together into a four-dimensional fabric called space-time. When you move through space, you are essentially borrowing some of your motion through time. The faster you move through the three dimensions of space, the less room there is for you to move through the dimension of time. This leads us to the heart of Einstein's elegant but terrifying math. The Lorentz factor. This is the mathematical scale that determines just how much time will bend to accommodate your speed. At human speeds, walking, driving, or even flying in a commercial airliner, the Lorentz factor is so close to 1 that the effects are invisible. We are like ants crawling so slowly across a vast, elastic sheet that we never notice it stretching. But as you begin to push toward the cosmic speed limit, the stretching becomes violent. At 50% of the speed of light, the effect begins to manifest, and time slows by about 15%. It is a noticeable lag in the rhythm of the universe. But as you hit the 90% mark, the world as you know it dissolves. Time for the traveler is now running at less than half the speed of the world they left behind. But even more haunting is the threshold of the extreme. At 99% of the speed of light, the Lorentz factor accelerates toward infinity. Time for the traveler slows by a factor of 7. 1 year on the ship is 7 years on Earth. At 99.9%, the ratio becomes 22 to 1. If you could somehow reach 99.999% of the speed of light, you could travel to the center of our galaxy, a journey of 26,000 light years, and only age a few decades. While back on Earth, the very species of humanity might have evolved or gone extinct. You would be a ghost, a relic of a forgotten era, propelled into a future that has no memory of you. This is the universe's way of enforcing its speed limit. It does to use a wall or a barrier. It uses time as a buffer. The faster you try to go, the more the universe slows you down in the dimension of time to ensure you never, ever cross the finish line of light. Yet, there is a profound loneliness in this discovery. The person on the ship feels nothing unusual. To them, their coffee pours at the same rate, their thoughts flow with the same agility, and their watch ticks with the same familiar rhythm. This is why it is called the theory of relativity. There is no master clock in the center of the universe. Time is an individual experience, a subjective shadow cast by your own motion. The only way the difference becomes real is when the two observers meet again and realize they are longer in sync. This break the symmetry of existence is what makes Einstein's revelation so haunting. It suggests that we are all living in our own personal temporal bubbles. And the only reason we feel we are in the same now is that we are all moving at roughly the same sluggish pace on this blue marble. When we look at the stars, we are not just looking across vast distances. We are looking through the distorted lens of time. We are seeing light that has fought through the warping of space-time to reach our eyes. We are part of a grand, cosmic machine that values the speed of light above all else, even if it means stretching the lives of sentient beings into impossible shapes. As we move from the theory into the cold, hard evidence provided by the world around us, we begin to realize that we are not just observers of this phenomenon, we are its subjects. We are tethered to a reality where the faster we chase the light, the further we drift from the people we love who remain in the shadows. The price of speed is the loss of connection, a trade-off that the universe demands with cold, mathematical precision. As we delve into the actual experiments that have proven these mind-shattering concepts, ask yourself, if the very fabric of time is this fragile, what else in our reality is merely an illusion waiting to be unmasked? The abstract corridors of theoretical physics are often dismissed as the playgrounds of dreamers. But there comes a moment when the chalkboard equations must face the cold, unyielding scrutiny of the physical world. For decades after Einstein published his special theory of relativity, the idea of time dilation remained a haunting ghost in the machinery of science, a mathematical necessity that seemed too strange to be true. To suggest that a clock could change its rhythm simply because it was moving felt like heresy against the very definition of reality. Yet, the universe does not yield to our comfort. It yields only to the truth. The transition from Einstein's thought experiments to undeniable proof is a journey that took us from the vatu of space, the frantic interiors of subatomic particles, proving that we are living in a world where time is as fragile as a glass sculpture. The first major confrontation between theory and reality occurred in 1971, in an experiment that remains one of the most elegant and daring in the history of science. Physicists Joseph Hafele and Richard Key did something that, on the surface, sounded absurdly simple. They bought tickets on commercial airliners. They didn't just bring luggage. They carried 4 cesium beam atomic clocks, the most precise instruments of timekeeping ever devised by human hands. These clocks do not rely on gears or springs. They count the ultra-stable vibrations of atoms, ticking with such accuracy that they would not lose a second in millions of years. The plan was to fly these clocks twice around the world, once westward, and then compare them to an identical set of clocks that remained motionless at the United States Naval Observatory. The emotional weight of this moment cannot be overstated. If the clocks returned and showed the exact same time as their counterparts on the ground, Einstein's legacy would have crumbled. The world would have reverted to the Newtonian safety of absolute time. But when the planes touched down and the data was analyzed, the results were staggering. The clocks that traveled eastward, moving in the direction of Earth's rotation, and thus at a higher net velocity, had lost 59 nanoseconds. The clocks that traveled westward had gained 273 nanoseconds. To a human being, a nanosecond is an invisible sliver of existence. But to the universe, it is a definitive signature. Hafele and Keating had caught the universe in the act of stretching time. They proved that even at the relatively sluggish speed of a Boeing 747, the fabric of reality was already beginning to warp. The airliners were, in a very literal sense, rudimentary time machines, while the Hafele-Keating experiment settled the debate for the macroscopic world. The most violent and undeniable proof of time dilation was being uncovered in the invisible realm of subatomic particles. Deep within the Earth, in the circular tunnels of particle accelerators like the Large Hadron Collider, we push matter to the very edge of the abyss. Here, we deal with particles like muons, unstable, heavy cousins of the electron that are born with a built-in expiration date. A muon has a natural lifespan of about 2 microseconds. In our world, that is a blink so fast it barely exists. Even traveling at nearly the speed of light, a muon should only be able to cover a few hundred meters before it decays into a burst of energy and vanishes. However, when we observe muons created by cosmic rays in the upper atmosphere, something impossible happens. These particles are born miles above the Earth's surface. According to Newtonian physics, they should die long before they ever reach the ground. Yet, our detectors on the surface are constantly bombarded by them. Because from our perspective, the muon is moving so fast 99.9% the speed of light to the moon, its life is still only 2 microseconds long. It feels no different. But to us, watching from the outside, the muon's internal clock is ticking in slow motion. Its 2 microseconds are stretched into tens, hundreds, or even thousands of microseconds in our frame of reference. This allows the particle to survive its long journey through the atmosphere and reach the soil. We are witnessing a living ghost, a particle that is surviving past its death simply because it has mastered the art of high-speed travel. This brings us to a terrifying realization about the scale of the universe. If a tiny particle can survive for longer than its nature allows, what does that mean for us? In our particle accelerators, we routinely witness time slowing down by factors of hundreds. We see matter refusing to age, refusing to decay, and refusing to obey the standard passage of the days. This is not a quirk of the equipment. It is a fundamental law of the architecture of space-time. The universe enforces its speed limit, the speed of light, by demanding that time be variable. It is if the cosmos has a built-in governor that prevents any object with mass from ever reaching the ultimate threshold. And it uses the dilation of time as the primary tool of enforcement. As we look at these experiments, we must also recognize the profound connection between motion and gravity. Einstein realized that it wasn't just speed that bent time, but the very presence of mass itself. This is why the GPS satellites discussed earlier are such a complex marvel. They are caught in a dual-ended tug of war. Their speed makes them younger, but their distance from the Earth's heavy mass makes them older. We live in a delicate balance of these two forces every single day. Every time you look at your position on a digital map, you are interacting with a system that has to solve the riddle of the Haffel-Keating experiment and the mystery of the atmospheric moon simultaneously. We are longer living in the world of 1895. We are living in a world where Einstein's impossible thoughts have become the invisible infrastructure of our civilization. There is a certain melancholy in this evidence. It tells us that our experience of now is entirely dependent on where we are and how fast we are going. Two people can never truly share the exact same moment if they are in motion relative to each other. We are all drifting through our own unique streams of time, separated by nanoseconds that, given enough speed, could turn into years or centuries. The history of these experiments is the history of humanity realizing its own isolation within the fourth dimension. We have moved to the scientifical, what if to the scientific it is. We have measured the heartbeat of the atom and found it to be inconsistent. We have chased particles to the brink of the speed of light and watched them defy death. When we consider the sheer precision required to measure these effects billionths of a second, we realize how close we are to the edge of understanding. The Large Hadron Collider is not just a tool for smashing atoms. It is a window into a reality where time is a fluid, not a constant. It is a place where we can watch the laws of the universe break and reform in real time. As we transition from these proven, historical facts into the more mind-bending paradoxes that arise when we push these laws to their ultimate extreme, we must carry this evidence with us. The dilation of time is not a fantasy. It is not a trick of the mind. It is a measurable, physical truth that has been verified on airplanes, in satellites, and in the deepest laboratories on Earth. It is the silent rhythm of the cosmos, a rhythm that tells us that the faster we run, the more the universe will stretch the seconds to keep us from ever reaching the end of the line. We are passengers on a journey through a flexible reality, and the evidence is all around us, ticking away in the silence of the atoms. Beyond the sterile environments of laboratories and the cold precision of atomic clocks lies a psychological and philosophical frontier, their identity. If time is a fluid, and if speed is the vessel that navigates it, then we must eventually confront the most haunting consequence of Einstein's reality: the twin paradox. This is no longer a simple discussion of shifting nanoseconds on an airplane. It is a profound exploration of what happens to the human soul and the biological clock when we push the laws of physics to their breaking point. To understand the twin paradox is to understand that the universe does not just warp time. It can effectively sever the ties between two lives that began as one. Imagine two identical twins, Alex and Jordan, standing on a launch pad. Their DNA is a mirror image. Their hearts beat in a synchronized rhythm. And until this moment, they have shared every second of their existence on Earth. Jordan remains on the ground, a tether to the familiar world of seasons, years, and steady aging. Alex, however, boards a starship capable of reaching 90% of the speed of light, destined for the star system of Proxima Centauri. As the engines ignite and Alex vanishes into the black velvet of the void, the symmetry of their lives is shattered. From Jordan's perspective on Earth, Alex's journey is a long, agonizing decade of waiting. On Earth, the clocks tick forward, the seasons change, and nearly 4 years pass before the starship's return. But for Alex, encased in a bubble of extreme velocity, the experience is radically different. Because Alex is moving through space at 90% the speed of light, his motion through the dimension of time is forced to slow down to accommodate the universe's absolute limit. To Alex, the journey to the stars and back feels like a standard mission. He eats, sleeps, and breathes in a world that feels completely normal. His watch ticks with the same familiarity it did on Earth. Yet, when he finally touches down and the hatch opens, he steps out into a world that has moved on without him. While he has aged only 1 years, his brother Jordan has aged over 9 years. A gap of 5 years has opened between them, a gap carved out of the very fabric of space-time. The twin stayed behind is now years older than the one who traveled. Alex has not just traveled through space. He has leaped into his brother's future. This is the point where the mind begins to recoil. For decades, critics of Einstein argued that this was a logical impossibility. They claimed that since motion is relative, Alex could just as easily say that Earth was the one moving away from him, and therefore Jordan should be the younger one. This is the heart of the paradox. But the universe has a definitive answer, and it lies in the physical reality of the journey. To return to Earth, Alex had to turn his ship around. He had to accelerate, decelerate, and change his frame of reference. That change of direction, that physical act of turning, is what breaks the symmetry. It anchors the time dilation to Alex's frame of reference. The universe knows who moved and who stayed, and it exacts its toll in the form of biological years. But what happens when we push this to the absolute extreme? What if Alex didn't stop at 90%? If the ship reached 99% the speed of light, the rift between the brothers would become a chasm. At 99%, time for Alex would slow by a factor of 7. A 1-year journey for him would mean returning to find Jordan 7 years older. At 99%, the ratio becomes 22-1. At this speed, Alex could take a short 10-year voyage and return to an Earth where over 2 centuries have passed. Everyone he ever loved would be dust. The language of his people would have changed. The technology of his era would be in a museum. He would be a living relic, a man out of time, an immigrant from a past that no longer exists. There is a profound, almost cosmic loneliness in this realization. It suggests that the faster we reach for the stars, the further we drift from the human experience. If we ever develop the technology to bridge the vast distances of the galaxy, we will have to accept a world where interstellar travelers are perpetual orphans of time. A captain could go on a mission to a neighboring star and return to find her children are older than she is. The biological hierarchy of family, the linear progression of generations, and the very concept of a shared history would dissolve under the weight of the Lorentz factor. We are used to thinking of time as a universal constant that binds us together, but Einstein reveals it to be a personal shadow that stretches or shrinks depending on how fast we run. This phenomenon also forces us to rethink the nature of the now. If Alex and Jordan are separated by years, despite starting at the same moment, which now is the correct one? The answer is both and neither. There is no objective present. Every point in the universe has its own rhythm, its own pace, and its own unique history. We are all island universes, floating in a sea of space-time that refuses to synchronize. The twin paradox is the ultimate proof that the universe values the speed of light above all human connections. It will stretch a human life, it will delay a heartbeat, and it will freeze a moment in time just to ensure that the photon remains the absolute master of reality. The emotional weight of this is staggering. We often think of time as a thief that steals our youth. But in the realm of relativity, time is a sculptor that shapes us based on our motion. As we look at the stars, we must realize that they are not just distant in miles, but distant in years. To travel to them is to undergo a transformation that is as much temporal as it is physical. Alex and Jordan's story is a warning that our grasp on reality is tenuous. We live in a world where the laws of physics can literally tear a family apart. Not through violence, but through the simple, elegant act of moving fast. As we stand on the precipice of this understanding, we realize that the universe is far more mysterious and indifferent than we ever imagined. It is a place where the future can be reached by simply running the horizon at a blistering speed. But it is a one-way trip. There is no rewind button in relativity. You can leap into the future, but you can never return to the now you left behind. You can see the end of the world, but you can never go back to tell your friends about it. The price of the ultimate journey is the ultimate isolation. When we contemplate the twin paradox, we are forced to ask ourselves, what is the value of a year? Is it a collection of heartbeats? Or is it a shared experience with those we love? In a universe where time is relative, the answer becomes a haunting reflection of our own choices. We are travelers on a flexible tapestry, and the faster we go, the more we realize that time is not the enemy. It is the very medium of our existence, a medium that we are only just beginning to understand. As we prepare to summarize these profound truths, and look toward the ultimate structure of space-time, we must carry the image of Alex and Jordan, with us two brothers separated by the cold, mathematical grace of a universe that refuses to wait for anyone. The journey through the mechanics of time dilation leads us, inevitably, to a place where science borders on the spiritual. We have seen how satellites drift into the future, how particles defy decay, and how brothers can be severed by the cold mathematics of velocity. But as we stand at the end of this exploration, we must confront the final, most profound question. If time is flexible, then what is the true nature of the universe we inhabit? Albert Einstein did not just give us a set of equations. He ripped away the veil of a static reality and revealed that we are living inside a four-dimensional masterpiece known as space-time. To others that recognize that our human perception of a past, present, and future might be nothing more than a persistent, albeit convincing, illusion. In our daily lives, we treat time like an arrow shot from a bow moving in one direction, at one speed, toward an inevitable end. But the dilation of time proves that the arrow can slow down, that it can curve, and that its flight is entirely dependent on the person watching it. This led Einstein and the physicists who followed him to a concept that is as beautiful as terrifying. The block universe. In this model, space-time is a solid, unchanging block that contains every event that has ever happened, and every event that will ever happen. Your birth, your first breath, your current moment of watching this video, and the eventual cooling of the sun are all etched into this block simultaneously. There is no now that moves through the block. There is only our consciousness drifting through it, like a needle on a vinyl record. This means that the past has not disappeared, and the future is not a blank slate. They are both there, fixed in the geometry of the cosmos. If time dilation allows Alex to jump into Jordan's future, it is only because that future was already there waiting for him. We are not creators of time. We are merely passengers on a flexible tapestry. This realization brings a haunting sense of order to the chaos of existence. It suggests that while we feel the weight of every passing second, the universe itself is a timeless structure of infinite complexity. We are like characters in a book who only see one page at a time, unaware that the ending is already written on the final leaf, existing at the exact same moment as the first sentence. But where does this leave our sense of agency? If time is a dimension as real and physical as height, width, and depth, then our movement through it is governed by laws that are indifferent to our desires. The dilation of time is the universe's way of maintaining harmony between light and matter. It is the ultimate expression of balance. Every time a star collapses or a galaxy spins, the fabric of space-time ripples, and time itself adjusts to ensure that the speed of light remains the master of all. We are part of a grand, cosmic symphony where every note is perfectly timed, even if the musicians are all playing in different temporal keys. As we reflect on the secrets of lucid cosmos, we must acknowledge that our exploration of time dilation is more than just a lesson in physics. It is a lesson in humility. We are biological entities whose senses evolved to hunt and gather on a slow-moving planet. Yet we have been gifted with the intellect to perceive a reality that our bodies can never truly feel. We have measured the nanoseconds of a satellite and the lifespan of a moon, peering behind the curtain of the great architect to see the hidden machinery of eternity. It is a privilege that comes with a heavy burden knowledge that our time is a precious, fleeting, and highly subjective gift. The legacy of Einstein is not found in the textbooks, but in the way we look at the night sky. When you gaze at the stars, you are not seeing the universe as it is now. You are seeing a collection of thens. You are looking at light that has traveled for thousands of years, warped by gravity and stretched by its own journey. You are seeing a graveyard of stars that may have died before humanity even existed, yet their light reaches you at its own unwavering speed, having survived the stretching of time itself. You are, in every sense of the word, looking at a living history. Time dilation is the thread that connects us to those distant fires, a reminder that in the eyes of the cosmos, distance and duration are one and the same. There is a silent, breathtaking grace in the way the universe protects its secrets. It allows us to glimpse the warping of time, yet it prevents us from ever truly mastering it. We can leap forward, but we can never go back. We can see the future of others, but we can never regain our own past. It is a one-way mirror, a door that only opens toward the horizon. This is the ultimate safety valve of reality. It ensures that the causality of the universe remains intact, preventing us from undoing the very fabric that created us. We are permitted to be travelers, but we are never allowed to be gods. As we close this chapter of Lucid Cosmos, I want you to take this feeling with you, the feeling of being small, yet connected to something infinitely vast. The seconds that are ticking by right now are your personal contribution to the history of space-time. They are unique to you, shaped by your location, your motion, and the very mass of the planet beneath your feet. You are a unique heartbeat in a sea of relative rhythms. This is the beauty of the universe. It is a place where everything is connected, yet everyone is experiencing a slightly different version of the truth. What lies beyond this understanding? Perhaps there are dimensions we have yet to perceive. Or perhaps time is even more fluid than Einstein dared to imagine. As we continue to push the boundaries of science and wonder, we do so with the knowledge that the universe will always have another secret waiting in the shadows of the next nanosecond. The mystery of time is the mystery of ourselves. We are beings of time, born from the stars and destined to return to the silence of the block universe. But while we are here, while our needle is still moving across the record, we have the power to wonder, to learn, and to appreciate the magnificent coiling of the seconds. Thank you for journeying with us through the heart of Lucid Cosmos. This exploration was made possible by your curiosity and your support. If this journey, the fourth dimension, has changed the way you look at your watch or the stars, then our mission is complete. Remember, in a universe where time is relative, the only thing that is truly absolute is our drive to understand it. Keep looking up, keep questioning, and never stop seeking the secrets that are hidden in plain sight. Until our paths cross again, in the next corner of space-time, keep chasing the light.